Hi, I'm Billy from Greenwood Solutions. Solar panel efficiency. They're getting more efficient, these solar panels. And in this presentation, we're going to look at what does that mean, how important is it, and are there more important questions to ask when selecting the correct solar panel for your next project. If you like the videos we're producing, hit that subscription button. Let's get stuck into it. So what is solar panel efficiency? It's the measure of the amount of solar energy which falls on a paneled surface, converted into electricity. And the average panel conversion efficiency has increased from 15% from a few years ago to now 20% plus. This has resulted in the power output of a standard sized panel to increase from 250 watts up to 340 watts. So how is solar panel efficiency determined? Basically, there are two main factors. The cell efficiency based on the design and the type of silicon used, monocrystalline, polycrystalline, amorphous, how the cells are configured, connected, and the size of the panel. Now this is determined by cell structure and base silicon materials utilised. It's calculated by what is known as the fill factor. So this is a product of voltage and current. And features include the silicon type, as mentioned before, and the number of buzz bars or connections on the actual panel itself. So in this example, we have panel brand and model, and I have blanked out the actual brands. It shows the length and width and the area in meters squared. So obviously that's the length times the width and converted into a meter squared situation. So you can see the first one, the REC, the area in meters squared is 1.78536 meters squared. The wattage of the panel is 380 watts, and the watts per meter squared is 217, and there's the efficiency. So the 217 watts per meter squared directly relates obviously to the claimed efficiency, which is 21.7%. So you can see in this situation we have got panels ranging from 20.16% in the second last row up to 21.7% in the top row. So how important is panel efficiency? If you've got plenty of roof space or plenty of ground mount space, then the efficiency of the panel is important, but not that important, unless the cost of installing that panel from a labour and materials perspective outweighs the lesser cost of a less efficient panel. I've looked at a range of panels and I've analysed them from the point of view of, for every kilowatt installed, how many kilowatt hours will that panel produce over its lifespan? So we have a table here with various panels. We have 1, 2, 3, 4, 5 options with different wattages. We have the number of panels installed, a system size in kilowatts, as you can see, and then the degradation of that particular panel from the data sheet. And you can see it ranges from, in the first year, from 2% up to 3%, and there's one example at 2.5% for the first year. Now all panels degrade a fair whack in the first year, but after that, for the next 2 to 25 years, you can see the degradation varies. So this is separate from the overall efficiency of the panel, which is based on standard test conditions in that first year, or right at the beginning of the first year. Now what I've done, I've looked at the total output over 25 years in megawatt hours. And this is based on 3.6 kilowatt hours produced per 1 kilowatt installed. But in the last column, I've calculated the total output per kilowatt installed over 25 years in megawatt hours. And this is because the panels are a different wattage, and as you can see, if I'm installing 500 panels, I have different system sizes depending on obviously the individual panel wattage. Now, some more examples. In this situation, I've assumed a savings based on a levelized cost of electricity of 3 cents per kilowatt hour over 25 years, and then a system size of 50 kilowatt, 100 kilowatt, 500 kilowatt, and 1000 kilowatt. In other words, 1 megawatt. And you can see the difference in the savings. So we have panel efficiency, panel degradation, the cost to install, the cost of materials, the time value of money, and how much that panel or that array will produce over its design lifespan. And of course, the other question, will the business be around in 25 years' time? Now, panels degrade in the first year, and usually it's around a 2% mark. Some panels more, some slightly less, but the majority of panels will degrade 2%. In other words, their output at the end of the first year will be 2% less than for the rest of the year, the previous year. Option 1. You've been quoted $1.40 per watt plus GST for a 500 kilowatt system using Tier 1 panels. In other words, panels that have been completely manufactured by the one company. And the panel efficiency is good, but not the best, and it's at 17%. Now, the degradation in the output after the first year is 2%, right? Which is a bit of a norm. But after that, 0.7%. Up until 25 years. So a bit higher than some of the more premium panels. And you have plenty of roof area for the panels. So you could put on a less efficient panel. In other words, a 17% efficient panel. Option 2. This option you've been quoted $1.50 a watt plus GST for a 500 kilowatt system using Tier 1 panels. Panel's efficiency is excellent, it's 21.7%, so it's more efficient than the other panel. The degradation is the same in output after the first year, it's 2%. After that, it's 0.25% up until 25 years. And again, you've got plenty of roof area for the panels. So which option is the better value? As you can see from the table, option 1 and 2 both have a system size of 500 kilowatts, we've established that. The cost difference is $50,000, option 2 costs $50,000 more. It has a higher panel efficiency. The degradation in the first year is the same as option 1, 2%. It's when you get to the degradation in years 2 to 25 that you can see a difference, a considerable difference. Now, the levelised cost of electricity over 25 years, in this case, I've made it $0.5 per kilowatt hour, so 50 cents per kilowatt hour. Now, the savings are quite considerable, as you can see, the savings between the two. With all of this, you have to incorporate the time value of money in any of your calculations. A cheaper panel will cost less per watt, and as the system size gets bigger, it can be in the order of 50 or 60 or 70 or even 100 or $200,000 difference between option 1, less efficient panel, and option 2, a more efficient panel. It's when you start looking at these degradation rates and factoring in the cost of installation per watt and the dollar cost per watt of what you're being offered as a consumer. Conclusion, solar panels have become more efficient in the last few years, in some cases greater than 20% efficiency. If limited space is a factor, panel efficiency is extremely important. But there are many things must be looked at in regards to choosing the right panel. The rate of degradation of the entire life of the panel determines lifetime output. Thanks so much for watching our presentation on solar panel efficiency. Hopefully it answered a few questions. But if you've got more questions or some inquiries or even some answers, feel free to drop us a line. And if you like what we're doing, hit that subscription button. Bye for now, and looking forward to presenting more information on commercial solar and renewable energy in general. See ya.